Good day, pre-calculus. How's everything? This is Mr. Langston, your host in section 1-5. And that title, totally forgot what the title is, and it's analyzing graphs of functions. But the first thing we're going to do is our warm-up. And this is stuff that I taught you yesterday. We have f of x is equal to g of x. I need to find the values of x for which f of x is equal to g of x when f of x is equal to x squared plus 1 and g of x is equal to 3x minus x squared. So the first thing I'm going to do is take and plug it in from S.C. Johnson, a family company. I'm going to plug in x squared plus 1 for f of x. So I'm going to put that there, x squared plus 1. And I'm going to plug in 3x minus x squared, 3x minus x squared for g of x. And now I'm going to get everything on one side so I can solve everything on one side. So it's either going to be all this over on this side, or I'm going to take all this and put it over this side. Either way, it's going to end up being the right answer. Personally, I like taking this and put it over here. Now, the reason being is if I move this over here, I'm going to have to subtract x squared. And I'm going to subtract x squared here, and that's going to give me negative 2x squared. And then I'm going to have to deal with the negative in the leading coefficient. And I hate having a negative in the leading coefficient. So my personal choice is to just bring the other side over. I'm sorry, I'm repositioning myself. I'm actually doing this on the weekend, and I don't necessarily have a desk area, so I'm actually solving this on the bed, and it's kind of getting uncomfortable for my back. So let's do this. I'm going to use red. So I have negative x, wrong-o. I want to take care of this. Get rid of these. So I'm going to add x squared, and I'm going to subtract 3x, and I'm going to subtract 3x here. Now I'm putting this minus 3x over here because I don't have a match on this side of like terms that I can stack it. So I'm just going to take care of it like that. Now, when we do this, this cancels out, this cancels out. I am left with 0 on my right side. And now I'm just going to combine like terms and bring them down. So I'm going to combine x squared and x squared. That gives me 2x squared minus 3x and plus 1. I'm going to make that equal sign a little bit better. And that equals 0. So now I need to solve this. Now I can solve this by using factoring. I can solve this by, well, guess and check. I can also solve this by the quadratic formula. So either one, I'm going to use factoring because, well, I think factoring is easier than quadratic formula. It's just me. So when you factor and when you have the leading coefficient, or the which basically means take the x squared, the coefficient of x squared, when it's not 1, when that leading coefficient is not the number 1, you're going to put whatever it is, and x on the bottom. And I'm going to show you why, but not right now. So just put this 2x on the bottom, and I'm going to take and multiply 2 times 1. That gives me 2. I'm also going to take this middle term, negative 3, put it on the bottom. So now I'm asking you, find 2 numbers that multiply to give me the number 2, and that add to give me the number negative 3. Can you find it for me, brother student or sister student? And these 2 numbers are negative 2 and negative 1. So negative 2 times negative 1 is positive 2, and negative 2 plus negative 1 is negative 3. Now, let me show you the reason I added these numbers in the bottom, the 2x's in the bottom. It's because, and we only do this when this number here is not a 1. So I'm going to simplify and keep them as a fraction if I can. And of course I can. The 2's cancel out, so it becomes -1 over x. And this doesn't simplify. So that means that my binomials are x minus 1 and 2x minus 1. So x minus 1 times 2x minus 1 gives me 2x squared minus 3x plus 1. And now to solve it, split it up. So I've got x minus 1 equals 0, and I've got 2x minus 1 equals 0. So add 1 to both sides. Plus 1, plus 1, plus 1, plus 1. And now I end up with 2x equals 1, or x has to be 1/2. Or I've got here x equals 1. So at x equals 1/2 and x equals 1, these two functions, f of x and g of x, end up being equal. I've cleansed the daemon. So what I've got here is analyzing graphs of functions. That's the section we're covering today. Our focus standards is functions and their graphs. Our objective, we are analyzing graphs of functions. What are we going to do? Analyze. So our language objective is you're going to be able to communicate with each other and articulate the processes utilized in analyzing graphs and functions. So the first thing we've got is I want to teach you the idea of finding a domain, finding a range, and the values of the functions at f equals, let's say, a number. So f equals f of -1 or f of 2, where x is a value. So first thing, before I teach you that, I want to teach you what is called, and I should have made it its separate slide, but you know what? We do need this graph, so I'm just going to call it right here interval notation. Now, what interval notation is, it's a way of representing ranges. And when I say range, I'm not talking about like a range of a function. I mean ranges of values. So from like 0 to 7, those are ranges. Interval notation represents ranges. And the way it represents it, it uses either brackets or parentheses or a combination of brackets and parentheses. So it's totally a combination. Now, brackets, and I'll put that right up here. Brackets means it touches, or it also means closed circle. And parentheses means it, of course, doesn't touch, or open cycle. Open circle. And that's a T. I do not know what happened there. So that's kind of like the basics of interval notation. You'll understand it once we start doing an example. So I've got interval notation. Now, one thing I want to teach you is negative infinity and infinity. Oh, by the way, that's not the answer to domain of f, okay? I should put it somewhere else. Let's do negative infinity, infinity. Now, the thing with negative infinity and infinity, if I go forever in this negative x direction, I'm going negative infinity. And if I go forever in this x direction, I'm going infinity. So that's like the basic idea. Now, one thing I want you to understand, though, is you can never reach infinity. You can reach a really high number. Or shall I say, in this case, a low number or a high negative number. But you're never going to fully reach negative infinity, because whatever number you reach, somebody can always go past that number. Somebody can always go one more. So you'll never reach negative infinity. So when we represent negative infinity, we represent it with a parentheses. And that means it's never going to touch negative infinity. You can't touch infinity or negative infinity. So both of these get represented by parentheses if we use interval notation. And you also represent open circles with the parentheses. Now, the closed circle, that is a bracket. Use a bracket for that, so because it touches. So let me actually give you an idea. And first thing, we're going to look at the domain. Okay? So the domain is the x values. All right? The domain is the x values. And if I project this down to the x-axis, I've got an open circle here. The graph continues along all these x values, and it ends with an open circle there. So I got a closed circle here, closed circle here, and an open circle here. So I start at x equals -1. The graph ends at x equals 5 with an open circle. So I can say the domain is all values for which x is less than 5 or x is greater than or equal to -1. Now, this is what you're used to seeing. But using interval notation, we can say x exists, and we can use this funny little e. It's just like making a letter C, and then you go like that. That means exists. So that's all it means, just x exists. So I'll put it up here to remind you. Exists. X exists from, and now it's a closed circle. So we use a bracket, -1, all the way to 5, but it's an open circle there. So we're saying x exists from -1 to 5. And that is your first introduction to interval notation. Now, another thing we're going to do is we need to find the range. I'm going to skip this middle part right now. Let's just find the range. Okay, and the range is all the y values. So what we can do is we can project everything on the y-axis. So here is the top. The max value for y is at 3. And then it will take every single y value on, because it's continuous, takes on every single y value until it reaches the bottom y value of -3. So if I wanted to find the range, I would say y is less than or equal to 3, and y is greater than or equal to -3. Now, I can represent that with interval notation. I say y exists from, and it's closed circle at -3, closed circle at -3, and closed circle at 3. There you go. Y exists from -3 to +3, and everything else in between. So that's interval notation. Next thing I want to talk about is finding function values for f of -1 and f of 2. And I need to change position because my back is hurting. So give me a second. I'm old, man. Give me a break. So I've got right here function values f of -1. All I'm asking is when f is a fancy way of saying y. So f of -1, I'm saying what is the y value when x is -1? So I just go over to x being -1 and find its y value. Here's my point, and its y value is, at x equals -1, the y value is 1. So I say f of -1 equals 1. And what about f of 2? I go to where x is 2, right here, and I'm going to find the point. Here's the point when x is 2, and the y value when x is 2 is -3. So I'm going to say f of 2 equals -3. And we're done. Shazam! That's it. So, next thing I want to teach you, it's vertical line test for a function. Now, the rule with the vertical line test is very simple. Okay? If you make a vertical line anywhere in the function and it crosses that function twice, or shall I say, if you make a vertical line on any graph and it crosses that graph twice, it's not a function. Or if it crosses it 3 times, not a function. So it is only a function if the vertical line, only a function, if line crosses 1 times. So it can only cross 1 time. So for instance, this is what I'm talking about. Sorry, lousy position. Need to switch. Switch. This is what I'm talking about. I'm going to make a bunch of vertical lines. Boom, right here. Boom, right here. Boom, right here. All of these vertical lines, except for the one right here. If I make one here, it crosses once. But guess what? This vertical line crosses twice. Not a function. This vertical line crosses twice. Hey, it's not a function. This vertical line crosses twice. The graph's not a function. All you need is one vertical line to cross twice, not a function. And that's just it. So for this one, I'm just going to say, not a function. Let's look at this one. Let's make more vertical lines because I like making vertical lines. All these vertical lines only cross the function once. They just cross it 1 time. Crosses the graph here, crosses the graph here, crosses the graph here, crosses here, crosses here, crosses here. Each line crosses the graph once. As a result, yes, it is a function. And let's look here. Let's make vertical lines. Okay? Boom, 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 boom. Okay, so the vertical line crosses this one time. Okay? Crosses it once. So in this case, I can say, yes, it is a function. But because I have a vertical line here that does not cross the function at any point, it is not what we call, it is not continuous. Okay? So it's not continuous, but it is a function, just not continuous. And when I say continuous, I mean it doesn't run together. You have to draw, lift up your pen and draw. So that means just not continuous. So next, you have increasing and decreasing functions. So you need to tell whether it's increasing or decreasing. And it says graph is increasing if the y values of the function are increasing. The graph's going up. Oh my God, how surprising. Yeah, these are notes. from the book. Graph is decreasing if the y values of the graph are decreasing or the graph is going down. Oh my God, who could ever notice that? Okay, so let me actually just really talk about math here. The graph is decreasing when the slope is negative. It is increasing when the slope is positive. And it's constant when the slope is 0. Decreasing when the slope's negative. Slope 0, constant. Increasing, slope is positive. Now, you're just like, what do you mean? This doesn't have a slope because it's a curve. Well, what you do is if you make tangent lines, and tangent lines are lines that cross the graph in one point only. So if you make tangent lines on this graph, you'll notice that the slopes of these tangent lines are negative. And that's what I'm talking about. So the slopes of the lines that touch the graph are negative. That's why it's decreasing. Or shall I say that's an indicator that it's decreasing. So if you haven't already done this with your partner, talk about what constitutes increasing, decreasing, or constant functions. Be sure to communicate about the slopes of the functions and how they relate to increasing, decreasing, or constant functions. You need to go to your Haiku Learning webpage and fill in. Now, this is something where it's in your own words you're going to be discussing. And if you need help starting it, I've got something right there. Increasing functions are, decreasing functions are, constant functions are. So fill that in. And now let's go to example 3. Describe where the functions is increasing, decreasing, or constant. So it's positive slope. So it's increasing. Slope is 0. So it's constant. And now I've got, in this case, negative slope. So it's decreasing. And I can write it like this. It is increasing. And let's do interval notation. So it's increasing, and I'm assuming this goes on forever. Goes on forever. And I'm assuming this goes on forever, because that's the way the graph looks like. So it's increasing from negative infinity, from x is equal to negative infinity, and all the way to 1. Now, here's the thing. At 1, it immediately changes from increasing to constant, and it gives me a corner. If you are ever given a corner, I can't say whether at 1 it's increasing or decreasing, because if I draw my tangent lines, I can draw many different tangent lines at that point. Okay, many different ones. So I can't say anything definitive about that point. Okay, that's a critical point right there, but I can't say anything definitive. So I'm going to say from negative infinity to 1, not including 1, it's increasing. And I'm going to also say that it's decreasing from, and again, I can't say anything about this point. There's too many tangent lines I can make. Okay, it's a corner. So it's decreasing from, did I say 1? I'm crazy. I was looking at the y value. It's increasing from x is negative infinity all the way to 0. Okay? Sorry, I was looking at the y value. I need to be looking at the x value, but I caught myself, so I'm lucky. So it's decreasing from x is 2, and I can't say anything about that point because there's too many tangent lines. It's a corner all the way to infinity. And now we're going to talk about where it's constant. So let me just make room. Okay, making room. Making room. So it's constant from, now I can't again say this slope, or sorry, not this slope. I can't say anything about this point here because I've got a corner. It's changing from increasing to constant really fast. So I'm going to say it's constant from 0, don't include 0, all the way to 2, don't include 2. Now, let's look at this one. I've got this graph here. Now, I know it's increasing here because if I draw tangent lines, the slopes are positive. So it's increasing. Now, here's the thing. It's increasing from, so that's going to be negative infinity in the x direction. And understand, when I go out here, it's going to be like way down here, way down there. So, but nonetheless, I can keep going. I got x values all the way to the left that I can do. So it's increasing from negative infinity, and I don't know why I did that parentheses. So negative infinity all the way to -1. Now, here's the thing. If you have a corner, I can't say whether at that point it's increasing, decreasing, or whatever if I have a corner. But if I have a smooth curve, I can say whether it's increasing and decreasing. I'm allowed to. So in this case, I'm increasing from here until I get to x is -1. So I'm increasing for all the x values here to x is -1. But I'm not going to do a parentheses. Because I have a smooth curve, I can actually draw a tangent line to this. I can draw only one tangent line. It's right there. It's nice and flat. And in fact, same here. I can draw a tangent line here. It's nice and flat. Now, if I tried to do it here, I would actually catch a bit of the graph here. So there's actually only one tangent line I can draw. And it's this one. And that slope is 0. That means at these maxes and minimums, my slope is 0. I have a constant. Okay, so it's increasing from negative infinity to -1. Negative infinity to -1. It's decreasing. So decreasing from -1, x is -1, so projected onto the x-axis. So x is -1, all the way to, in this case, oh no, we got to find the root. So well, oh wait, why am I finding the root? I don't even know what I'm doing. Down here, sorry, brain farted, brain fart. So it's decreasing from here all the way down to here. So x is 1 to, or sorry, -1 to 1. That's where it's decreasing. Now, it is constant at x equals -1 and x equals 1. So got my graph right there. Oh, by the way, I didn't put this increasing part. I did this increasing, but I didn't put this increasing. So I'm going to say it's increasing also from x equals 1 to infinity. There you go. Sorry, I'm recording this on a Saturday, so my brain's in vacation mode, okay? So What we've got here is tests for even and odd functions. And to test for an even and odd function, it's an even function if I plug in a negative number, and that would be the same as if I plugged in a positive number. It's an odd function if I plugged in a negative number, and that would be the same if I take the normal, I plug in a positive number, and then I turn my answer negative. So let me show you what I'm talking about. So I got right here. I'm going to test for an even function, and I'm going to test if it's an odd function. Now, one thing to tell you about even functions and odd functions, it can only be one of them, or the last thing is it could be neither. So if it's even, if I test it and I come out that it's an even number, an even function, then guess what? It's an even function. That means it can't be an odd function. And if it comes out to be an odd function, well, it's an odd function. It can't be an even function. And if both of these tests fail, then it's just neither. Now, the way you can do the test is you can plug in a bunch of points. Okay? So, for instance, I can plug in -1 into this, and then I can plug in 1 and see if they're equal. And I can plug in -2 and I can plug in 2, see if they're equal. Plug in -3, plug in 3, see if they're equal. But here's the thing, I want to test for all points. So to test for all points, what I'm going to do is I'm going to plug in -t and t. And that's a way of testing whether it's even or odd. Plug in -t or t. So talking about it right here, look at this. So I'm going to test to see if it's an even function. So I have g of x is equal to x cubed minus x. I'm just rewriting it. I don't know. I always do that. I'm going to plug in, for an even function, I need to see if g of t, or sorry, g of -t is equal to g of t. I need to find out. So I'm going to plug in wherever I see x, I'm going to plug in -t. So I've got -t cubed minus a -t. Is that equal to g of t? So for this one, I'm going to plug in t. So I've got t cubed minus t. So -t cubed is going to give me, or should I say -t quantity cubed, is going to give me -t cubed. And minus a minus is a plus, so that's plus t. And I want to find out, is it equal to t cubed minus t? Is it equal? I need to know, is it equal? Well, just by looking at it, it's not equal to it. So in this case, it is not an even function. It is not even. So now I'm going to test it for odd. So to test for an odd function, I need to find out if g of -t, if that's equal to negative g of t. So g of -t, I need to find this out. G of -t, I'm going to plug it in again. So I've got -t quantity cubed minus a -t. Is that equal to negative and whatever g of t is? So I'm going to have t cubed minus t. When I simplify it, -t quantity cubed is -t cubed plus t. Minus a minus is a plus. And is that equal to, let's distribute this negative, -t cubed plus t. Well, these are both the same. So the answer is yes, it is an odd function. Yay! For this one, I'm going to test whether it's even or odd. Let's start with even. And remember, even has h of negative t equal to h of t. So I'm going to plug in wherever I see x, I'm going to plug in negative t. So I've got negative t quantity squared plus 1. And is that equal to h of t? So wherever I see x, I'm going to plug in t. T squared plus 1. So negative t quantity squared is t squared plus 1. Is that equal to t squared plus 1? Yes. So this is even. And if I did these and they both became no, then it's neither. And if I did this and it was a no, and if I did the test for odd and it was a no, then it's neither. So even Las Vegas. So that's it. And the last thing we've got is average rate of change. Now, the average rate of change of a function is the rate of change of a function or the slope of a function at 2 points. And what you're going to do is they're going to give you your 2 points when they ask you for the average rate of change. They're going to be like, what's the average rate of change from x1 equals negative 2 to x2 equals negative 1? Okay. What they're meaning is you've got the point of negative 2 and you find the y value. So it's negative 2, that's the y value. And then you find the y value of this x value. So at x2 is negative 1, the y value is 2. And now you draw a line that cuts the graph at 2 points, at the 2 points. This line is called a secant line. And a secant line is a line that cuts a graph at 2 points. Now, to find the average rate of change, all you do is you find the slope of that secant line. The slope of the secant line. That's all you have to do. You guys know what a slope is. It's y2 minus y1 over x2 minus x1. And that's the slope. So all you have to do is find the slope. Now, you're going to see books writing average rate of change like this. Okay? And I taught you guys about function notation here. That when it says f of x, it's a fancy way of saying y. In this case, when I plug in x2, it's a fancy way of saying y2. And this, f of x1, it's a fancy way of saying y when the value is x1. So the y value when I plug in x1, that's y1. So it's y2 minus y1. See, all this is just the slope equation, y2 minus y1 over x2 minus x1. That's all it is just the slope equation. So what you're just going to do is find the slope. So I know from this graph here that my point was negative 2, and negative 1, 2. So I've got negative 2, and negative 1, 2. So this is x1, y1, x2, y2. So I've got 2 minus a negative 2. And that's all over negative 1 minus a negative 2. So if I simplify that, that becomes 2 minus a minus is a plus, so plus 2. And that's all over negative 1 minus a negative 2, so negative 1, again, plus 2. So this becomes 4 over 1. Or I can say average rate of change and define where it's from. Okay? From x1 equals negative 2 2, x2 equals -1 is 4. Or I can say is 4 over 1. Now let's go back to this because I do want to show you this. Look at this right here. If I wanted to get from this point to this point, I'm going to have to go up 1, 2, 3, 4, and I'm going to have to go over 1. So if I represent rise over run, up 4, I rise 4, and I run 1. My slope is 4 over 1. Again, that's the average rate of change. It's your slope of the secant line, 4 over 1. That's it. I've cleansed the daemon. There's really nothing more. So what you guys need to do is go on to Haiku Learning with your partner, talk about average rate of change of a function, what it means, and how would you find it? What it means and how would you find it? Or what does it mean? Okay. Now, go to your Haiku Learning, talk about it, put it down. If you need help, I'm going to start you off. You can start with this sentence. You don't have to, but you can. The average rate of change is, and finish off with your own words. All right, well, that's it, you guys. I hope you enjoyed section 1-5, and if you didn't enjoy it, I hope you learned something from it, because you know what? If you're not going to enjoy it, at least learn something from it. Do your homework. If you have any questions, you can speak with me after class, during nutrition, during lunch, or even before school. I get to school at around between 6 o'clock to 6:30. So that's all I have for you. Nothing else. I hope you guys have a great day. Peace.